Chapter 13 is all about trig functions. Section 13.1, right triangle trig. Trig is the study of the relationships among the sides and angles of right triangles. Now you learned a little bit about trig in your geometry class. Trig functions. The three trig functions on the left you are already aware of. You have the sine curve, cosine, and tangent. One way you were probably taught to remember that was so, ka, toa. Opposite, hypotenuse, and adjacent is what those three stand for. Now the three on the right are three new trig functions. We have cosecant, sorry about that, secant, and cotangent. Now, if you notice, there's a special relationship between the sine and the cosecant, the cosine and the secant, and the tangent and the cotangent. They are actually reciprocals of each other. So yes, they are new, but they aren't anything super crazy and different. Now, just like I said, they are reciprocal functions, so we could also think of cosecant as 1 over sine, or we could think about the sine of theta as 1 over cosecant of theta. Secant is 1 over cosine, and the same way we can think about the cosine of theta as 1 over secant. And then cotangent is 1 over tangent, which means I could think about the tangent as 1 over the cotangent. Find the values of the 6 trig functions. Well, first I would want to find the remaining side. So I would do x squared plus 3 squared equals 5 squared. So x squared equals 16. So x equals 4. Now the sine of theta is opposite over hypotenuse. The cosine of theta is adjacent over hypotenuse. The tan of theta is opposite over adjacent. The cosecant of theta is hypotenuse over opposite. The secant of theta is equal to the hypotenuse over the adjacent, and the cotangent of theta is equal to the adjacent over the opposite. A capital letter will be used to denote both a vertex of the triangle and the measure of the angle at that vertex. The same letter in lowercase will be used to denote the side opposite it. For example, if I have a triangle labeled like this, that means this lower angle is angle A, this upper angle is angle B, and the right angle is angle C. The side opposite angle A is A, the side opposite B is little b, and the side opposite C is little c. Example 2, if the cosine of A equals 2/5, find the value of tangent. Well, what I would do would be I generally draw out a triangle, and I put angle A somewhere. Now 2 over 5 means the adjacent side is 2 and the hypotenuse side is 5. So then I would find the other side using my Pythagorean identity, my Pythagorean theorem. So x squared would equal 21. So x equals the square root of 21. So that means this last side is equal to the square root of 21. So then the tangent of A is equal to the opposite over the adjacent. Write an equation involving sine, cosine, or tangent that can be used to find the value of x. So what I would look to see the relationship of the angle given to the two sides. And in this case, I would want to use that the cosine of 30 would be equal to x over 8. So then solving, I get 8 times the cosine of 30 equals x. Now you would use your calculator. Make sure that it's in degree mode. Okay, to check that, you want to click on the word mode, which is next to the second button, and then you'll see the words degrees or radians. Make sure that the degrees is highlighted. After plugging that into my calculator, I get 6.93. Solve XYZ. When we have to solve it, we have to find all the missing angles as well as all the missing sides. So I would first start with angle Y, because that's probably the easiest. That's just going to be 180 minus 90 minus 35. So I get that angle Y is 55 degrees. Now, do not use that angle, because what if we made a mistake while finding it? So what we're going to do is always use the given information to find the other missing sides. So if I first want to find x, okay, then I look at the relationship of x with the angle on the side I'm given. So I'm going to use that the tangent of 35 equals opposite over adjacent. So x is going to equal 10 times the tangent of 35. And this is when I would go to my calculator and I would plug it in. Make sure it still is in degree mode, which it should be. Oops. X equals 7.002. Now if I want to find z, I look at the relationship between z10 and angle 35. And that's going to be the cosine of 35 equals 10 over z. So z equals 10 divided by the cosine of 35. So z equals 12.208. Solve triangle ABC. So if I want to find angle A, let's say I want to use the sine function. So the sine of A is going to be opposite over hypotenuse. Now there should be a button above your sine that's in blue on your calculator that reads sine to the -1. This will allow me to find the angle given to side lengths. So again, you want your calculator in degree mode, and then this is what you would type into your calculator. And you end up with that A would equal 22.62 degrees. Now if I want to find angle B, let's switch it up a little bit. What if I wanted to do the cosine of B equals 5 over 13. So that means the cosine of -1, 5 over 13. And you could use any trig functions. It does not have to be this one. 67.38. Now what I would do, I would suggest doing these separately. And then to check, make sure that angle A plus angle B plus angle C does equal 180. That should be your check. In order to construct a bridge across a river, the width of the river at that location must be determined. Suppose a stake is planted on one side of the river directly across from a second stake on the opposite side. At a distance 50 meters to the left of the stake, an angle of 82 degrees is measured between the two stakes. Find the width. So in this problem, I would use the tangent of 82 would equal W over 50. So then W would equal 50 times the tangent of 82. So that means that my width is 355.77 meters. Again, just plug this right into your calculator. Angle of elevation. Angle of elevation is the angle formed by your line of sight from the observer, which is down here, and a line parallel to the ground. So it's them being parallel and then just turning your head and looking up at something. Angle of depression is the angle formed by the angle of sight from a plane and a line parallel to the ground. Now what's neat is these two angles, so the angle of depression equals the angle of elevation. The aerial run in Snowboard Utah has an angle of elevation of 20.2 and its vertical drop is 2,900 feet. Estimate the length of this run. So what I would do, I would use my sine of 20.2 equals opposite over hypotenuse. So my L would be 2,900 divided by the sine of 20.2. So my length would be 8398.5 feet. So you could estimate that to be 8,400 feet. That would be a good estimate.